A storm rips through a medieval village at 80 miles per hour. Modern houses would collapse, but these buildings, they just flex and breathe like they're alive. No nails, no cement, not even a single screw. Just wood, dirt, and a trick stolen from Viking warships that engineers today are only now starting to understand. The craziest part? These houses could last 500 years while your modern home starts falling apart after 30. Here's how they did it. Medieval builders had a massive problem. Wood rots. Touch wet soil and your entire house turns into mush within a decade. But they couldn't just pour a concrete foundation like we do today because, well, they didn't have concrete. So they came up with something better. Dry stone foundations. Imagine stacking rocks without any mortar or glue, just pure skill and gravity. These builders would dig shallow trenches and carefully place flat stones on top of each other, creating a platform that lifted wooden beams several inches off the damp ground. The genius part? Air could flow underneath, keeping everything dry. But wait, here's where it gets interesting. These weren't just random rock piles. Each stone was chosen for its shape and fit like a 3D puzzle. The weight of the entire house pressed down on these stones, locking them together tighter than any cement ever could. When the ground shifted during storms or freezing winters, the stones just adjusted themselves. No cracks, no breaks, just constant adaptation. The wooden beams sitting on top of these foundations were usually made from oak, the toughest wood they could find. And here's a detail most people miss. They didn't just plop the beams down. They carved the bottom surfaces flat and sometimes even charred them with fire. Burnt wood resists rot better than raw wood because the char creates a protective barrier against moisture and insects. Think about that. They literally burned their building materials on purpose to make them last longer. And it worked. Some of these foundations are still standing today, over 800 years later, holding up buildings that have survived countless storms, wars, and centuries of harsh weather. Now here's where medieval builders completely flipped the script on everything we think we know about construction. Modern buildings are built to be rigid, stand strong, don't move, resist everything. Medieval walls? They were designed to move. The technique was called stavak construction, and it came straight from shipbuilding. Picture this: vertical wooden posts planted firmly into the ground or onto the stone foundation, each one carved with long grooves running down the sides. Horizontal boards would then slide into these grooves, but here's the trick: they weren't nailed down or glued, they just sat there, loosely held in place. Why would anyone build a wall that's basically loose? Because when a storm hits, the wall doesn't fight the wind, it flexes. The boards can shift slightly in their grooves, absorbing the force instead of resisting it. It's the same principle that kept Viking longships from breaking apart in ocean storms. The hull would bend and twist with the waves rather than snap under pressure. But hold on, you're probably thinking. Wouldn't loose boards just fall out? Nope. Gravity and overlapping design kept everything in place. Plus, the posts were spaced perfectly, so the boards created a tight seal against weather while still maintaining that crucial flexibility. Oh, and here's something wild that'll blow your mind. The exterior walls didn't even support the roof. That's right. The walls were basically just wind barriers. All the weight of the roof was held up by internal pillars running down the center of the building. This created massive open halls inside, sometimes stretching 80 meters long with barely any interior walls. These halls were so big that entire communities could gather inside during harsh winters. Families, livestock, food storage, all under one roof. And because the walls weren't load-bearing, if a section got damaged, they could just pop out a few boards and replace them without the whole structure collapsing. Medieval people basically invented modular construction 1,000 years before IKEA made it trendy. Iron nails were expensive, like really expensive. Most medieval villages couldn't afford to use them for construction, and honestly, they didn't need to. They had something better: tree nails. Tree nails, or trunnels, were wooden pegs made from hardened oak or ash. But these weren't just twigs shoved into holes. The process was an art form. First, the carpenter would carve the peg from the toughest, densest part of the wood grain. Then, and this is crucial, they'd dry it out completely, either by hanging it near a fire or just letting it age for months. When it was time to build, they'd drill a hole slightly smaller than the peg and hammer it in tight. Here's where the magic happens. Over time, the peg would absorb moisture from the air and the surrounding wood, causing it to swell. As it expanded, it created an incredibly strong bond that actually got tighter over time. Unlike iron nails, which rust and weaken, tree nails got stronger with age. But tree nails were just the start. Medieval carpenters were masters of joinery, the art of connecting wood without fasteners. Mortise and tenon joints were everywhere. A mortise is basically a hole carved into one piece of wood, and a tenon is a protruding piece carved on another that fits perfectly into that hole. Slide them together, and you've got a connection stronger than most nails. Then there were notched corner joints, where two beams would be carved with interlocking grooves and slots. Stack them like Lincoln logs, and they'd lock together so tightly that you couldn't pull them apart without destroying the wood. Some buildings used dovetail joints, where the wood pieces were carved with angled wedges that could only slide in from one direction. Once assembled, the joint physically couldn't come apart unless you reversed the entire construction process. The whole building was essentially a giant wooden puzzle. Every beam, post, and board was custom carved to fit exactly where it needed to go. No two pieces were identical because they didn't have factory machines cutting everything to standard sizes. Each structure was unique, built by craftsmen who understood wood like we understand smartphones. And honestly, the fact that these buildings lasted centuries without a single nail or screw makes you wonder if we've actually gotten worse at construction over time. Winter in medieval Northern Europe was brutal. We're talking temperatures that could drop well below freezing for months. So how did they keep these wooden halls warm without modern insulation or heating systems? Turf walls. Picture this. Over the wooden frame and boards, builders would stack layers of turf, basically chunks of grass and soil cut from the ground, over a meter thick in some places. These weren't just thrown on randomly. Each layer was carefully placed, roots facing inward to help bind everything together. The result? Walls that were naturally insulated, fireproof, and self-repairing. Grass kept growing on the exterior, with roots weaving through the turf like natural rebar, holding everything together. If a section got damaged, the grass would just grow back. But the real genius was in the roofs. First, they'd lay down a layer of birch bark. Birch bark is naturally waterproof. Native Americans used it for canoes for the same reason. It doesn't rot easily, it's flexible, and it creates a perfect moisture barrier. On top of the birch bark, more turf. Thick, heavy layers of soil and grass that served three purposes at once. 1. Insulation. 2. Weight to hold the roof down during storms. 3. Waterproofing that got better over time as the grass roots grew and intertwined. These roofs were so heavy that the internal support pillars had to be massive, sometimes entire tree trunks stripped of bark and sunk deep into the ground. But that weight was essential. In a storm, while other roofs would lift and tear off, turf roofs just sat there, too heavy to move, absorbing rain like a sponge and staying perfectly intact. And here's a bonus feature nobody talks about. In the summer, these roofs stayed cool because the soil and grass provided thermal mass. In the winter, the thick turf trapped heat inside. The building naturally regulated its own temperature. Some of these turf roofs even had wildflowers growing on them. Imagine walking through a medieval village and seeing houses with entire gardens blooming on their roofs. It wasn't just practical, it was beautiful. Everything we've talked about so far points to one revolutionary idea that medieval builders understood better than most modern engineers. Flexibility beats rigidity. Modern buildings are designed to stand firm and resist forces. Medieval buildings were designed to yield and adapt. Every single element, the loose boards in grooved posts, the wooden pegs that expanded with moisture, the heavy turf roofs that absorbed impact, the internal pillars that carried all the weight, was built to move slightly under pressure. When a storm hit, the walls would flex, the roof would settle, the wooden joints would shift microscopically, but nothing would break because nothing was fighting the force. The building absorbed energy like a shock absorber on a car. This is the same principle engineers are now using in earthquake-resistant buildings in Japan. Modern skyscrapers are designed with flexible joints and dampening systems that allow the building to sway rather than crack. Medieval builders figured this out 1,000 years ago, using nothing but wood, stone, and observation. Think about it. They didn't have computers running stress simulations or advanced physics textbooks. They just watched how ships moved in water, how trees bent in wind, and how natural structures responded to force. Then they copied nature. The result was buildings that could last for centuries with minimal maintenance. Some of these longhouses survived for 500 years or more, weathering countless storms, floods, and freezes. Meanwhile, modern houses built with concrete, steel, and advanced materials start falling apart after a few decades. Why? Because modern construction prioritizes speed and cost over longevity and adaptability. We build houses like they're products on an assembly line, not living structures that need to breathe and flex with their environment. Medieval builders treated their work like art. Every beam was carved by hand. Every joint was custom fitted. Every detail was considered. They weren't just constructing shelter. They were creating something meant to outlast generations. And maybe that's the lesson we've forgotten. Buildings aren't supposed to be temporary. They're supposed to be part of the landscape, adapting and surviving just like the people who live in them. So why did we stop building like this? Why did we abandon techniques that clearly worked for methods that produce houses falling apart in 30 years? The answer comes down to money and time. Medieval construction was slow. It took skilled craftsmen months or even years to complete a single structure. In our modern world, we want houses built in weeks, not years. We want them cheap, mass-produced, and identical. But here's what nobody talks about. Those medieval buildings didn't just last longer, they cost less over time. No constant repairs, no replacing rotted materials every decade, no tearing down and rebuilding every generation. We've traded longevity for convenience, and we're paying for it with homes that become money pits, constantly demanding maintenance and repairs. Meanwhile, scattered across Northern Europe, there are still buildings standing that were constructed before the printing press was invented. And the techniques aren't lost. Small communities in places like Norway and Iceland still build using these methods, creating homes that will outlast anything modern construction can produce. Some architects are even reviving these ancient techniques, realizing that the old ways might actually be superior. There's one technique we didn't cover though, one trick that medieval builders used to make their structures even stronger, something involving the way they harvested the wood itself. The timing had to be perfect, the moon phase had to be right, and if they got it wrong, the entire building could fail within years. But when they got it right, the wood became nearly indestructible, lasting longer than iron or steel. That technique was almost lost to history. Almost.